Good afternoon. This is David Eastwood, Geotech Engineering and Testing. How y'all doing? Um, this is the webinar on earthwork and quality control for residential, commercial, and public work projects. Webinar that we're doing for American Society of Civil Engineers, ASC Houston branch. We appreciate the opportunity. This presentation really talks about lots about earthwork testing, soil testing as it relates to earthwork, mass grading, land development stuff, subdivisions. Um, it also talks about concrete testing, how to test concrete. What are some of the things you have to worry about concrete when you pour? Uh, and talks a little bit about steel testing. So it's kind of a covers soils, concrete, and steel. So audience makeup, we've got a lot of civil engineers, so that's good. We've got a lot of engineers all listening. I think the last time we checked, there was like 220 people RSVP'd. So uh, if you need to reach me, my contact information is de@geotecheng.com. My phone number is 713-699-4000. This presentation is going to be on YouTube. If you go to Geotech Engineering and Testing YouTube channel, it's going to be posted there. You're not going to get everything the first run at this thing. And so if you can go back and watch it again and enjoy it. Geotech Engineering and Testing has been in Houston for about 37 years. We do geotechnical, environmental material testing and geoforensics, failures, roadway, bridges, residential, commercial projects. We've got 60 people, engineers, technicians. We work all over Texas, Louisiana, New Mexico, and Oklahoma. We have our own rigs, so we can go on projects quickly. If you have questions, please type them in the Q&A segment of the Zoom, and then I'll check on it and answer the questions as we go through. We're going to talk about quality control. Back in the old days when the Romans used to build their roads, they had their inspectors here. And these inspectors, they had spears. So if they failed the density and stuff like that, they will attack you with a spear. So that's all they used to build the roads. So when you start doing any kind of a development, site work, got to remove the grass, weed, existing foundations, paving, establish good drainage, compact to subgrade, 95% standard proctor density. That goes as well for roadway projects. You got to compact that soil, make sure it's dry. If the soils get wet, you open them up to dry up. You can throw some fly ash, cement, or lime on it to dry it up. If soils are sandy, use fly ash or cement for sandy soils to modify them. If you got clay, you would use something like quicklime or something like that. You can always remove and replace the soil, the bad soils with structural fill. In many areas, if it's a small area, you can just put bags of lime and that will dry it up. That clearing, of course, on a lot of the projects that we're doing on these land development projects, even roadways, the new ones, you got to go out there and clear a lot of the trees and roots and get all that stuff out. When you clear, you got to make sure you take all the roots out. You're not supposed to have any roots more than half an inch in diameter. So, for example, when you take that tree out there, all this has got to be mucked out. You got to go 3 foot, 4 foot deep, get out all the soft stuff up, come back in, put structural fill and compact it and test it all the way to the top. Make sure it's compact 95% standard proctor density and test with a nuclear gauge. Make sure it's properly compacted. Really soft stuff when you take the trees out. Here's a lot here. I was driving around. They cut the tree stump, but you can see all the roots all around. So roots from trees, extend all over the place. So you got to make sure you take everything out and make sure there's nothing bigger than half an inch. You just can't shove soil into the hole. That is not acceptable. You got to go in there and backfill and test it all the way to the top. No root organics. We don't like to have root organics out there on there on roadways, bridges, roadways, and land development projects, lots, and so make sure you don't have a root organic. This is a pad these guys are building out here. This is a project near Kingwood, and you can see all the roots that they got in the pad, and we rejected the pad. I mean, they had too much organics in it. See the tree trunk in there? They just buried it in the pad. All the root organics used to come out, nothing more than half an inch. They got to get them off site. If they're bringing the fill, we got to make sure the fill doesn't have root organics in it. That's not acceptable. All that needs to come out. No bricks, debris out there in your fill. That's not acceptable. No big chunks of rock, stuff like that. That's not acceptable. Perched water table. If you go out there, start building out there near the Woodlands area, go 290. Or if you go near Katy area, we have this geology where we have sandy soils over clay. So these clays are impermeable. So what happens is when it rains, water just sits in the sand and just generous perch water table. Just sits over here. Water's on the surface. It cannot penetrate. Regular water table could be about 20, 30 feet deep. It's a regular water table. Well, perch water table is about, 6 inches deep, 12 inches deep. So we got that out there near Katy, 290 area, parts of Fulshire, I-45 North, south of Loop 336 in Conroe, where you have this perch water situation. Just water sits out there on the ground. Doesn't go anywhere. So if you go out there and dig a beam out there for a slab, it gets filled up with water. You're going to have to dig that out, clean up the whole trench, make sure it's nice and compact before you pour the concrete. Pump that water out. Here's a site that's got perch water table condition. This site is near Katy. So you try to put a roadway on top of this, it's going to be very challenging. So that's what we call soil pumping. So you go out there and start driving these sites, your truck's gonna get stuck. It's just really soft near the surface. So how to improve sites that are pumping? Typically, the way we handle these things is we open it up to dry up, but that's not usually the case. What happens is because of Houston area, we get so much rain. When you open it up to dry up, it's going to rain on it, so all the work is going to go waste. You can improve drainage. You can do soil mixing. You can do chemical modification. You can do removal or replacement of the sand and silts that are pumping. Open it up, dry it up. You get those are to open up the silts and sands and let it dry up. Again, this is not a very practical solution. because of all the rain we getting. Drainage on a lot of projects where we got perch water table conditions, what we do is we go out there and dig out these what we call bleeder ditches. These ditches about 3 foot deep, about 4 foot wide, and we take them all the way to a detention pond or a channel and let these sand and silts dry. So as we drain the site, we take that water, we put these things, maybe 100-foot spacing, 200-foot spacing. Take them to a trench or a detention pond, and then you got to pump it out of sight, off site. Also, when we do projects where you got a detention pond, let's say you got a roadway, you got a detention pond or a subdivision, you do a mass grading and you got a detention pond, and you got these sandy soils. As you dig your detention pond, if you got a clay soil, or this is a clay soil, or if you have a channel that you're digging, and you got a clay soil, you put it on the back of the truck, bring it to the site, grade it, and start disc it into the sand and silt. And as you mix it like 60-40, 60% clay, 40% sand and silt, it makes enough pump. So that's a disking. Make sure everything is less than 1.5 inches in diameter. You can pulverize it with a pulverizer. Then you go back and compact it with a sheep's foot. You can do chemical stabilization. For example, if your soils are real sandy or clayey, you can use lime or you can use fly ash. This is a dry hydrate lime. If you got a clayey soil, for example, you can use that for sandy soils as well. It kind of dries it up too. Quicklime is the best thing to use. A lot of people use quicklime, and you go out there and spread it on the site. We don't recommend using lime slurry because it's got too much water in it. So I wouldn't use that. Too much moisture. You can use fly ash. Fly ash you apply dry, and you go out there and mix it in and compact it. Here's a typical lot out there north near Cypress Wood area where you got real sandy soils. Yeah, real sandy soils out there. So it was all pumping and everything. So we brought in fly ash, we dump it on the site. And these guys go out there and start spreading it out. Start mixing it in. Like that. So that's the fly ash and the soil. You can do the same thing with cement. That's kind of the mixture. Then you go out there and add water to it. Typically, we add 5 to 10% fly ash by dry weight. You add water to it, and you got to compact it quickly. Either use fly ash and lime, compact it quickly, otherwise you lose it. And you add the water in, you compact it. Here's they're using a steel drum roller. It becomes nice and hard. It's going to pass proof rolling. Check the density with your nuclear gauge. You can do a depth check. See how far the fly ash was mixed. You dig a hole. You apply phenolphthalein. Turns purple all the way down. So in this case, for example, that could have been, 8 inches, 10 inches. Removal and replacement. You can always remove that sandy, silty material and bring in a structural fill. Doesn't have to be select structural fill. It could be structural fill. Select structural fill is a soil with a liquid limit less than 40 pi between 12 and 20. Structural fill can be just regular clay, sandy clay, lean clay, back clay. You bring it in, it lifts, compact it. Kind of expensive. So depending, how you're going to go about it, the cheapest way is probably going out there, do soil mixing or having bleeder ditches. If you're in a time crunch, then you get into doing chemical stabilization such as lime or fly ash or cement. Disking, when you bring in fill to the site, you cannot compact big chunks of clay. So you got to chop it to 1.5 inch in size. That's how I use a disc. You got these plates. They cut through the soil. Chop it to pieces. So once you disc the stuff and compact them, then you can build on it. Now, if you build a roadway or a subdivision roadway, it doesn't matter. One of the first things you got to do, even the lots, you got to check the proof rolling. You get a loaded dump truck, you fill that with soil, you run it through the lots or the paving area, roadway. Hopefully, there's no deflection. Okay. This is not acceptable. This is not acceptable. Too much deflection. It's not acceptable. This is not acceptable. Not acceptable. Not acceptable. Not acceptable. Not acceptable. So if you don't proof roll your projects, because there's no way you can go check densities everywhere. So if you're just going out there and proof rolling it, you got to make sure you proof roll it. Make sure it's nice and hard. And you don't accept, significant deflections. Usually anything more than 2 inches or so, we don't accept. Earthwork for a single house, a lot. Here, these guys had perched water table. They have all these sandy, silty soils over there. They were going to build a house on top of that silt. So they just dug out all the silt and the sand. You can see that, the depth. And they brought in proof rolling it with a truck, took out the sand and silt, got to the clay, proof roll it, brought in structural fill, compacted it, test the density. Compaction, if your soils are clayey soils, we use sheepswood roller. You see that's a sheepswood roller. Like that, you compact it. If your soils are sandy, use a steel drum roller. Okay, this thing has vibration too. It densifies sand. So this is called steel drum roller. For grading purposes, we use dozer. We don't use dozer for compaction. We use pneumatic roller to seal the compacted soil so that the water doesn't get in there. It's nice and compacted. Smooth area, surface area. That's a pneumatic roller. You sheepswood compact it, and then you go back with a pneumatic on it to seal it. This is a pad here. You can see it's nice and crowned, positive drainage, using a sheepsfoot to compact it. Here we're using a steel drum roller to seal it. This is a compacted soil. You seal it with a steel drum roller here, so the water doesn't get in there easy. Here's a pad. Got a bunch of bird bath, low areas. This is one of our dogs, Mr. Patch. House construction. If you look at the commercial or residential construction, we got a lot of trees in Houston. So one of the first things that we have to do, cut those trees, do root raking, take out all the roots, anything more than 1/2 inch. Take out all the tree stumps. You don't leave them in there. And then you go in there and remove the grass. Go out there and grade it. You start bringing fill. Now, in this case, it rained. So if it rains and you got a bad drainage on the site, the water just sits on top of your pad. You got to pump all that water out. Do it all over. You pump the water out. You got to go back and proof roll it again. It's soft in here. Proof roll it. Proof rolling passes. If it doesn't pass, in this case, it didn't pass. So they had to go back and fly ash it and make it nice and hard. This is not acceptable. Bring in structural fill. Build your pad. Compacting 8-inch lifts. Grade it. Compact it. This is a sheep's foot roller. Build your pad. Positive drainage. Set your forms. Do the plumbing. The plumber is going to go tear up your pad. So you got to go behind the plumber with the jumper jack and compact all above the pipes. Of course, then they set the forms, and of course, you put your slab on it. You pour the concrete. If you're building a house, for example, if you're parts of Houston, you got really expansive soils. There's a concept called potential vertical rise. That's how much heat you can expect on the ground. For example, parts of Conroe is really bad, really expansive soils. Fort Wayne County, parts of it has got real bad soils. Sienna Plantation. So if you have any kind of movement more than 4.5 inches on your soils, you got to go back and treat those soils. You treat them with chemical injection. Make sure the heave is not excessive. Here, for example, you got a site with a PVR of 5.1. You got a lot PVR of 4.9, 5.2. So what we do in these cases, go back to either we do put select fill on these lots, or we do moisture conditioning, or we do chemical injection. So select fill, you can bring in fill, put in your lots. Select fill, soil with liquid limit less than 40, PI between 12 and 20. And so that's a low PI soil. It doesn't heave. That's select structural fill. You do moisture conditioning. You can also do moisture conditioning. Select fill is expensive. Moisture conditioning after the lots are in place is expensive. You add a bunch of water to your lot, top 2-3 feet, and you go back, recompact it. If your soils are compacted on the wet side, they don't heave as much. So it's called moisture conditioning. They do it all over Dallas, San Antonio, and Austin. Compact it with a sheep's foot. Compact your soils at optimum plus 5% or 4%. Then you got to go back, and cover it up. If they don't build on it within, I would say, 2 weeks to 30 days. You got to put some kind of a vapor barrier on top of it. You compact your soils at optimum. This is the Proctor curve. Optimum is 11% plus 5%, so about 16%. If the soil is compacted on the wet side, it doesn't heave as much. Cover the area that's moisture conditioned or chemically injected as soon as possible. Cover with the plastic. Chemical injection. We do a lot of chemical injection on projects in Houston. Sienna Plantation. Bunch of houses over there that are in chemical injection. Clay soils usually have negative charge. Water has got positive charge. Fat clays want to absorb the water, so the soils experience heave. So you do chemical injection with cation exchange. You remove the negative charge and replace it with a positive charge. Reduce the negative charge. So what you do, you remove the sodium and potassium, put calcium in there. So this water layer thickness becomes lower, the soil does not heave as much. So the way they do it is it's got these chemical injection tanks. They fill them up with water and chemicals. It's like sulfuric acid. And they go out there, inject it. This is sienna plantation. We inject it to the soil. All the way down. We go down 10 feet in Houston. We go down 15 feet in Dallas, San Antonio, and Austin. And inject the soils with the chemicals. These chemicals react with the soil, do cation exchange, and make the soils non-expansive. This is the hole that's going in. So if you're in one of those subdivisions out there in Rosenberg and Sugar Land and Fort Wayne County or North Montgomery County, or you Baytown out there, parts of all that whole east of Houston, you got really expansive soils. That's chemical injection. Soil types where chemical injections are effective with are soils that have a lot of cracks in them, shrinkage cracks. These shrinkage cracks basically occur because of the droughts that we have. So the more shrinkage cracks you have, the more chemical injection can travel. And of course, after the chemical injection, we go out there and test the soil, make sure it doesn't heave as much. Lot drainage, if you got projects like land development, you got to make sure you got positive drainage on your projects. The soil should be compacted properly and they have good drainage on them. Positive drainage, positive drainage, positive drainage, positive drainage. They got swale between these houses. Don't fill them up. That's where the water drains away. I remember in 1979, I bought my house. It had a swale on it. I went out there and filled up with sand. I didn't know what I was doing. But don't do that. These are the swales between the houses. Quality control, soil, concrete, drill piers. We're building pads for commercial projects or residential projects. We bring in structural fill, compact 95% of standard proctor density to build our pads and our lots. We've got proctor material. This is a natural soil, the black stuff. This is the fill material. This is sandy soils. I mean, lean clay. Okay, this fat clay, lean clay. That's a select structural fill. You get a bucket of the fat clay on the job site. That's kingwood, by the way. And sometimes you got to go to a pit to get soil. Now, the soils in a pit vary. Here's the soils are sandy. Here's a clayey. So the soils in the pit vary. So if somebody says, hey, I went to the pit and got this material, depending which part of the pit you go to, you're going to get different materials. So it's very important to get proper material from the pit. Somebody had a question, see if I can answer that. Oh. Let's see if I can answer it. It doesn't show. Unfortunately, it doesn't show the question and answer. Hey, Vicky. Yeah, can you come here? Say, get the IT here, so if you can figure out why the question and answer does not work. Somebody's got a question, but I can't open it up.
You won't click?
No.
Click on the QA. I don't know. It works when it's not.
Yeah. So I can, after, if you would send me a question after the meeting, you got my email, send it to me. Sometimes Zoom, the Q&A does not work. So depending on which part of the pit you are, they get the soil from the pit, you put it in the back of a truck. Here we go, good sandy clay soils. Put it in the back of the truck. and take it to the job site. So this is the structural fill. This is natural soils. You run a proctor test. You go out there and get that soil. You dry it all up, chop it to pieces. You take the organics out, roots. You add water to it, a different moisture content. Compact your soil. It's a 5.5 pound hammer drive, 12 inches in a 4-inch mold. You put in 3 layers, 5.5 pound, drop 12 inches, 25 blows per lift, 3 lifts. We do it compaction with the machine sometimes. Compacted lifts. This is the mold out here. You put the soil in it and then compact it. So you get the sample, you extrude it. You know the volume of it. You can measure that and you weigh it and you develop proctor curve. So you got the soil for different moisture and density. You got this proctor curve. It's the optimal moisture. This is the dry density. You want to compact your soils on a project. 95% is standard proctor density. 95% of 122 is about 115. And moisture contents plus and minus 2%. So that's 11 plus 2 and 11 minus 2. That's 9 to 13%. That's going to change for every soil. And if you go out there and run your proctor curve and then you run your string curve, see how strong the soil is, you'll find out you develop your maximum strength as where you develop your optimal moisture. So your optimal moisture, your dry density, maximum strength at near optimum. On small projects, you got thin lifts and you got to compact. You compact it in lifts. You can use jumping jack to compact stuff. Small sheep's foot, steel drum roller on small projects. Compact on thin lifts, like 2-inch, 4-inch. When you build pads, for example, for buildings, you dig beams out there. You don't use sand on your projects. Do not use sand on your slab areas. These sands are permeable. Water can get all over the place and cause subsoil heave. And also perch water table. So we don't recommend going out there building pads with sand. Use a structural fill to build your pad on there. Make sure it's all properly compacted, 95%. The plumber is going to come in and tear it up. Got to go behind it, compact it all around the plumbing with jumping jack. Make sure your grade beams are nice and square. All the loose materials need to come out. All the plumbing should be nice and neat. Run density test. The way you do a density test, you poke a hole in the ground and you make a probe. That's the hole. And then you go out there, put your nuclear source in there. This thing is the source, emits gamma ray. These are receivers. The more the gamma ray comes to the detectors, the looser your soil is. The less coming comes, the denser your soil is. So you run the density test, takes a few seconds. You get the compaction to make sure it's compact 95% standard proctor density. Again, the seal proctor in here, 95% of 122 is 115 at optimum moisture between 9 and 13. When they dig your beams on your project, all this got to be loose. This trash should not be in there. All that got to be removed. This is not acceptable slab. You know, they got all this gumbo clay in it, loose materials. This is not acceptable. This is not acceptable. Not acceptable. The busting the piers. You can see the steel for the piers. Really poor construction. Poor construction of the beams. Beams are not straight. Any loose materials on your pad got to be removed. Remove all the loosest stuff. Then you put your vapor barrier there. It's not acceptable. The pad that's just got rain on it after it was built. It's all soaked in. That needs to be redone. Got to remove it and replace it. You cannot put tree trunks in the beams because they got tree trunks, 26-inch trunk, 26-inch tree stump, 6 to 8 inch stump in the beam, 14-inch pecan, 37-inch from the form. We don't want to put trees near the slab. These trees got to be at least 20 feet away from your slab. Here's how you can set forms and make sure you have nice, clean grade beams. Saves you money on concrete. Here's when we had a lot of rain here in Houston. They were building the pad. So they put a tent on top of it to prevent it. Here's another pad in here. They built it out there. They let it sit. They put the plumbing in, let it sit. The gas grew on top of it. Not acceptable. They have to go redo it. They build a church on top of it. Removes grass and weed before setting the forms. If you're building a house, for example, all this grass got to be removed. You cannot build a house on top of grass. This is one of the subdivisions in Houston. They left the grass in there and they dug the beams and poured concrete on top of it. It's really a poor construction. So all the grass got to come out. Here's the makeup. They left the grass out there. You can see under the beams. So we got the grass there. So all that is rejected. Correct fill type placement. Don't go out there in Pearland and build a house slab and put a bunch of sand in there. You cannot use sand out there in your pad. It's permeable. It causes perch water table and heat. All the backfill around your pipes got to be structural fill. These guys went out there and start building a house in Pearland. They brought 30 inches of fill there. They didn't compact it. They were going to put a post-tension slab on top of it. Not acceptable. You can't do that. All that fill should have been compacted in 8-inch lifts all the way to the top. This is the fill they brought in. They said this is select fill. When we looked at it, it was fat clay with some sand around it. So we rejected it. It's not select fill. Chemical stabilization. So if you got a roadway project, you want to stabilize that soil. If your soil PI is just less than 15, use lime fly ash, usually in Houston. Within 15 to 35, you can use lime fly ash. Above 35, we use lime, okay? Lime stabilization, we use type A lime, type B lime slurry, but we use type B on our projects. Type C quick lime, we use that for drying up stuff. Type B lime slurry, cure 24-72 hours. Gradation, make sure you're on gradation at 50-foot spacing on your road project. 100% should pass 1.75 sieve. 85% should pass 0.75 sieve. 60% should pass number 4 sieve. Compacted optimum plus 3%. You go out there and remove all the grass. You bring in your lime. You apply the lime. Add water if you need to. They cure, usually 24 hours to 4 days. If your soil's of fat clays, we recommend 4 days. Go pulverize it, small pieces. This is the natural soils. You cure it for 24-72 hours. And once you pulverize it, that soil becomes like sand after you lime stabilize. Make sure you're on gradation. We don't want to have big chunks of soil in your lime stabilized subgrade. Compact with a sheep's foot. Seal it with a pneumatic. Run density tests at 50-foot spacing. You do depth check. Make sure the line was there to the proper depth. You dig a hole, you apply phenolphthalein. You measure the depth. If your lime's supposed to be 8 inches, it should turn purple to 8 inches. Okay, that's you do depth check. So you do depth check every 50 feet, density test every 50 feet, gradation every 50 feet. And this is the compacted subgrade. The lime should be nice and hard. So if you got a roadway, for example, that you do lime stabilization, as soon as you lime stabilize it, you put the steel and you want to pour concrete right away. You don't want that subgrade to dry up. See the shrinkage cracks? That sucks moisture out of the concrete and causes reflective cracking. You develop a lot of shrinkage cracks. So we don't want that. Not acceptable. Not acceptable. Not acceptable. You got to pour the concrete right away before you start having much shrinkage cracks. The way you find out how much lime you need, you can add enough lime to get your pI less than 20, or you can do what we call pH test to get a pH of 12.4. pH test is more accurate. You go in there, add lime to the soil, you measure the pH. When you see here about 12.4, here in this case about 7.5% lime by dry weight. That's what you need. Okay, do a pH test. You can also use this TxDOT deal curve depending on your pI. You go in here, percent, soil binder, you can see how much lime you need, but pH test is more accurate. Cement stabilization or fly ash modification, type of cement. We use cement type C150 type 1. You can do mixed dry or slurry, apply water, compact near optimum, compact within 2 hours. You scrape the grass and weed, add water if you need to. You apply cement, you can apply dry. Or we do a lot of slurry now. Most of the cement stabilization jobs we do is a slurry. We apply it in a slurry fashion. Go back with the pulverizer and mix it. Make sure you're on gradation. After mix, compact and finish within 2 hours. Compact it with a sheep's foot. Seal it with a pneumatic. Make sure you run the density test. If you do cement stabilization, make sure the soil meets density requirements. Now, when you do cement stabilization of soils, the soils becomes really hard. So if you put paving on top of it, especially asphalt, you can develop reflective cracking because of the cracking of the subgrade. So what you do micro cracking. So after you apply the cement stabilized subgrade, you get a steel drum roller. Usually 48 hours after cement stabilization, you do micro cracking. You go in there with a steel drum roller. This will induce micro cracks and relieves the tensile stresses. The base stiffness recovers. This is called autogenous healing. This will reduce reflective cracking in asphalt pavements. So you're going to have to do micro cracking if you got a project where you're doing cement stabilization, because it gets so hard. You go do the micro cracking to reduce reflective cracking. Lime fly ash stabilization. If your soils are sandy, we use a lot of lime fly ash stabilization. We use typically lime slurry, fly ash type C or F. Apply lime fly ash in the single mix. We can do that. Compact within 2 hours, no more than 6 hours after adding mixing of the last stabilizing agent. So you go out there first, apply a lime just like you would do it, let it cure. And then you pulverize it, you mix it. You go out there and apply your fly ash. And add water to it. Fly ash, we added dry. Complete within 2 hours, no more than 6 hours after the fly ash. Pulverize it. Compact it with a sheep's foot. Run density test, make sure it passes density. Concrete testing. Cold weather concreting. You cannot apply concrete when for more than 3 consecutive days, mean temperature drops below 40 degrees. Normal concreting can practice resumed once the temperature is 50 degrees for more than half a day and rising. Concrete, if it gets really cold, concrete should be protected from freezing below 32 degrees. And thawing until it at least gets 500 degrees, 500 psi. So what happens is if you in the wintertime you're putting the concrete in, you got to protect it until it gets about 500 psi. This can be done by putting blankets on it, heaters and stuff like that, and make sure your concrete is protected against freezing. Once it's got 500 psi, it can usually resist one cycle of another freezing again. Basically, if you pour concrete in cold weather, you get low strength. Low strength with gain with time, more void space in concrete, reduced rate of cementation or hydration, low durability. Hot concreting. Place concrete when the temperature of the concrete is between 75 to 100 degrees. Check the temperature of the concrete, 75 to 100 degrees. Some specs vary. So if you have poor concrete when it's hot, it will increase the water demand, accelerate slump loss, increase the rate of setting, increase tendency for plastic cracking, difficulties in controlling entrained air, critical need for prompt early curing, decreased strength, decreased durability, non-uniform surface appearance, increased tendency for drying shrinkage. So this is not cool if you pour concrete when it's hot. Concrete after rain. These guys poured the concrete when it started raining, washed off the whole cement off the concrete, left the aggregates in there. And you can see that. So you got to go there and jackhammer this out and do it again. When you pour the concrete, you got basically a concrete dump truck. You put it in a pump truck. You pump it in with the concrete. You should have a slump of no more than 5 inches. You pump it in like that. You got finishers to finish that foundation or slab that you're pouring. Make sure you got chairs. You vibrate. Make sure you don't have voids. Once you pour your slabs, if you got a big slab, you got to go saw cut it. Not for residential, for commercial projects, for example, or paving. If you got paving, you got to go saw cut it. 8 to 12 hours usually afterwards. You saw cut at 15-foot spacing usually. You got control joints. It's called control joints. That's control joints. It tells concrete where to crack. You saw cut 1/4 of the pavement thickness. So if your pavement is 6 inches, you saw cut 1.5 inches. It cracks below it. Slump test on your project, you should not have a slump of more than 5 inches. The slump, the way you do it is you got a cone like this. You put concrete in 3 layers, 25 blows per layer. You lift it up. This is a slump from here to here. If it's more than 5 inches, you reject the concrete. Like Fort Encounter requires no more than 6-inch slump. This is your slump from here to here. This slump is 11 inches, got too much water, you reject it. This is a very low slump here. Reject it. Too dry. This means what? Add 5 gallons of water to the concrete truck. Not a good practice. When you add 5 gallons of water to the concrete truck, for each 1 gallon that you add to 1 yard of concrete, 1 gallon of water will increase the slump by 1 inch. 1 gallon of water reduces compressive strength of a concrete by 250 psi. 1 gallon of water wastes 25% cement. 1 gallon of water increases shrinkage by 10%. 1 gallon of water increases permeability by 50%. 1 gallon of water reduces freeze thaw by 20%. 1 gallon of water reduces salt scaling resistance. Increases cracking. Increase air content. Increases segregation. Increases wear damage due to traffic. Increases dusting. Increases finishing time. So it's not really worth it. So make sure these guys don't add a bunch of water to the concrete on your job sites. Here's a project that poured the concrete wet. Getting cure properties, too much water. And you can see it's got low strength. You can just basically get that concrete with a key. So they have to go out and jackhammer this thing out and pour a new slab. You go past this. Making concrete cylinders. You've got a roadway you gotta do. You gotta have to basically get sample of that concrete, get in that wheelbarrow, bring it in, you put it in cylinders, a 6-inch by 12 cylinders. You put concrete in 3 layers. You rod it in, make sure you don't have voids in it. Clear to the top. Leave it on the job site 24 to 48 hours. Make sure it gets hard before you move it. Otherwise, you get low strength. You move it in a container like this, put it in the curing room, then you break it. So your concrete's supposed to be 3,000 PSI. Hopefully, you're going to get at least 3,000 PSI, 28 days. You break them at 7 days and 28 days. At 7 days, you got to get 70% of the concrete strength. So you're going to be at 2,100 PSI. Your concrete's got low strength. You can core it. That's the core. You cap the core and put it in a machine and you break it. In general, concrete core compression strengths are 15% lower than the concrete cylinders. That's because of the curing. Concrete cylinders are cured in a curing room with controlled temperature and humidity. In the field, in our hot summers, our concrete is cured differently. So when you core the concrete, you're going to get lower strength than cylinders. And so cylinders is just an indication of what the concrete strength is. But your actual concrete strength is by doing the cores. Swiss hammer tests. If you want to know the strength of that concrete, you can do non-destructive testing. You can use Swiss hammer. This is a device here. You clear the area. You bang this onto the concrete, and here you can read the strength of it. It usually overestimates concrete strength. You can do Windsor probe. You actually get a bullet with a gun, special gun. You shoot into the concrete. That's the bullet. And based on the crack it develops with the aggregate size, you can estimate the concrete strength. Drill pier observations. Dry method of construction. So on a lot of projects, when you do buildings, you use piers. These are auger rigs. This is the bell under reams for your buildings. You drill the holes with the auger. That's the auger rig. That's a reamer. Measure the depth. Make sure your hole is clean. You should not have more than 3 inches of water on the bottom of your piers. Check it with a hand penetrometer. Make sure you got strong soils. If you got soft soils, you got to call the structural engineer, increase the size of the foundation. And then you put basically bell tool out there and check the size of the bell. A lot of these contractors are getting paid by the number of piers they're put in. So they cut corners on the size of the bell. So you got to check with the bell tool, make sure you got the right size bell. You put your steel in there, start pouring concrete, make sure the concrete doesn't hit the sides. So you drill a hole first with an auger, you put your steel cage in, you trim the concrete from bottom up. That reduces segregation. So you want to pour from bottom up with the trimming. Casing method of construction. If you got sandy soils, you got caving problems with deep groundwater, and groundwater is not an issue, you can use casing method of construction. You drill a hole, you put your casing in. That's a pilot hole. You put your casing in. You start drilling through it. You take out the sandy soils, the clayey soils. You put your reamer in there, drill on the ream. You make your bell. You take it out. You put your steel in there. Like that. Pour concrete. Pull your steel cage out. I mean, your steel casing out. And go to the next one. You're trimming the concrete from top to the bottom. That's the trimming. It's like a funnel. It's got a hose goes to the bottom. Slurry method of construction. If you got a project like a TxDOT bridge project with piers, that's what they use. They use a slurry method of construction. So they go out there, they got a mud pit in here with bentonite. And they start drilling the holes. And they use a slurry here. It's a synthetic slurry. Put your steel cage in. Pump concrete from bottom up. Put the hose in the bottom of the hole. From bottom up. The slurry sticks to the sandy soils and cakes in there. And you also got hydrostatic pressure. Keep the hole from caving. So that's called slurry method of construction. You drill a hole, you introduce the slurry, you put your cage in there, and you pour concrete, trimming from bottom up. Concrete unit weight is 150 pounds per cubic foot. Slurry is maybe 77. So it removes the slurry. You put the slurry in a sump and recycle it in the next hole. Steel testing. A lot of commercial projects, we got to do bolt testing, stuff like that. We use ASTM 325 or ASTM 490 for bolt testing, for example. And, for like a ASTM 325, it's got a lower strength alloy. So you got to use a torque, average of 100, torque, 100, in this case, we have to use foot-pounds for half an inch, for 5/8, 200. Now, if you got a 490 situation where you got a stronger bolt with a stronger alloy, well, half an inch, you got to use 130 foot-pounds. So it's stronger bolts that we use on projects. ASTM 490 bolts are usually stronger than A325s because of the alloy. A490 bolts cannot be hot dip galvanized, but A325s can be hot dip galvanized to avoid corrosion. So they're lower strength, but you can galvanize them against corrosion. So these are the steel structures where they use. We use this torque wrench. You put the size of the bolt thing in there. You start turning the torque. Make sure it's properly turned in and it's got proper foot-pounds for the torque for the bolt. You read it here. Welds, there's got a lot of projects that we're doing like now, right now. There's a lot of welding going on. Visual observations of the welds is the kind of like one of the most simplest thing you can do. It is a basic non-destructive observation method that should be used before, during, and after fabrication. Visual interpretation is basic to all methods for non-destructive testing. So when they're doing welds on projects, you go out there, look at it, make sure it's nice and clean, doesn't have cracks in it. This is no good, got a crack in it. It's old weld in here, it's all rusting. So you got to check all these things visually to make sure it's nice and clean and meets project specifications. You got to get up there and test it and watch it, bang on it, make sure it's not hollow. You can do non-destructive testing. You can, depending what kind of a thing you're looking for, For discontinuities, you got looking for porosity, slag, or let's say cracking. In here, if you're checking for crack in your weld, you can use RT, which is radiographic testing. You can also use if you use radiographic, it says marginal applicability. So if you use ultrasound, is good. You can use penetrant testing. That's good. MT, magnetic particle testing, is good. VT, visual testing, of course, that's always good. And ET, eddy current, is good. So these are various techniques for non-destructive testing of the steel, for example. Use liquid penetrant observation is a sensitive method for detecting and locating discontinuities, such as cracks in materials. The method employs penetrating liquid, which is applied to the surface. The excess is removed, and you can see the discontinuity through the color in the crack. Here's you can see.
My name is Robert Mertz. I'm an ASTM in DT level 3.
Video here.
With the solutions, and today I will be performing a demonstration on how to perform liquid penetrant testing using solvent removable type. Okay, the reason why we want to do a demonstration on liquid penetrant test is just to explain how to do it properly. And some of the reasons why we do it is for cases where you cannot do magnetic particle testing, such as stainless steels or other materials that are non-ferromagnetic. The first step in the procedure would be to clean the test plate. So the first step, take the cleaner. I need to use a lint-free cloth. That's key. You can't use paper towels. You want to use a lint-free cloth. If it's really greasy, dirty, you can spray directly on the plate. This plate is very clean, so I'm going to clean this. Hopefully you're in a nice, well-ventilated area. I don't think you can over clean at this point. Make sure you get along the toes of the welds very good. And then let that sit for a minute, let that evaporate. Okay, the next step, now that the material or test plate or surface that we're going to examine is clean thoroughly, we want to spray the liquid penetrant. Make sure the can is check and weld. Spray it, just lightly spray it. It doesn't take a whole lot. And we want to let that sit, depending on the temperature of the base metal. It can be anywhere from 5 to up to 30 minutes. If it's way below 50 degrees, you probably shouldn't even be doing the test. The colder the material is, the longer you need to let it sit. That time that it sits is called the dwell time. So in this case, for the temperature of the base metal and the procedure that we would be following, we would let this dwell for about 8 to 10 minutes. I'm going to let this dwell, then we'll come back and do the next step. Okay, the next step, now that we've allowed our penetrant to dwell the proper time, now we want to clean the product off the test plate.
I want to show you kind of towards the end what it looks like when after he plays it, and you can see the weld.
So apparently, you know, with PT, the indications have to be open to the surface. If they're subsurface, this test method will not work. So in case, you know, in this case, the test plate apparently has no flaws that are open to the surface, because I don't see anything that's not supposed to be there, any type of flaws. There may be flaws in there that can be detected by other methods, such as ultrasonic testing or magnetic particle testing, because if you were to see a flaw, it would look similar to the type of bleed out that you see across this edge right here. The few little spots that I see simultaneously, and it actually has some indications in it. If you look real close right here, you can see some bleed out through the capillary action and the penetrant.
So the other test we do as non-destructive is magnetic particle. Is used for locating surface or near surface discontinuity, cracks and stuff. This method involves establishing a magnetic field. Here's a little video.
My name is Mike Porter. I'm the corporate NDT level 3 for Alta Vista Solutions. And this is part of a video training session. And we're going to be performing magnetic particle testing on a painted component. So what we're going to do is we're going to demonstrate the proper technique to perform magnetic particle testing through a layer of paint on a component. Typical applications from ASTM E709 is a particular standard that we're working to, the American Standard Testing of Materials, and it doesn't allow you to test through paint. You need to test through uncoated surfaces. You're allowed 1 or 2 mils of paint, and then that 15 mils of paint on it. Find the particular anomalies that you're looking for and demonstrate the technique. So this is a magnetic particle yoke. We're going to start over here. One of the things that we teach our technicians is the proper technique to applying the particles. As you apply the particles, you want to actually just float them on. You don't want to dump them on with a can such as that. You just want to be able to lightly float the particles on. And the same thing with a puffer. When you blow the particles away, you want to be a little tender and a little sensitive and make sure that you have the right technique. Move down across the plate, making sure that we have overlap. So I make sure that I test 100% of this particular component. I don't see anything there. I'm going to move down again. A 2-inch long crack in the heat affected zone. So as I talked about before, that it's important to know the techniques and the proper technique of blowing the particles off, because if I use too much force, especially on a painted plate as opposed to an unpainted plate, I can actually blow the particles away and you no longer see the crack. So again, it's important to have the proper technique in floating the particles on and watching them form, and then also the proper particle.
So another non-destructive testing, of course, radiographic, like X-ray. So you get your weld and X-ray it.
Radiography testing utilizes ionizing radiation to achieve an image of an object on several different viewing medias. This may be gamma rays, or as in this case, X-rays. The examiner marks the weld to be inspected with a measuring tape. This will be visible on the X-ray. Thus, he will know how to determine the exact location of possible irregularities. The film is mounted on the object, and the X-ray tube is set up carefully.
The other method, of course, is the other method is ultrasound, ultrasonic method. We use ultrasonic method on a lot of medical stuff too. Observation method applicable to almost all materials, geometries, and it's a really great technique.
It is possible to investigate whether there are discontinuities under the surface using ultrasonic sound waves. Ultrasound has such a high frequency, people cannot hear it. The vibrations can, however, be measured with sensitive measuring equipment. Using this storage vessel, a weld is checked for internal discontinuities. First, the object being examined must be cleaned and free of any material that may interfere with the exam. Simply said, it works as follows. Sound waves are transmitted into the material with the transducer, and an echo is sent back from the rear wall or discontinuity. By registering this echo, we can deduct the thickness of the material, or if a discontinuity is present. In case of a discontinuity, sound is echoed back faster. Thus, we can see if the material wall is thinning, for instance, by corrosion. The examiner first applies a contact fluid to enable the ultrasonic feeler to make proper contact with the material. This bonding layer serves to conduct the sound waves into the material. Without the contact fluid, they would immediately bounce back from the surface. A transducer converts an electronic signal into ultrasonic sound waves. It can both send and receive. The ultrasound equipment captures the reflected waves and converts this into a visual signal. This enables
That's a typical, some pictures of ultrasound they're doing on projects on welds. Of course, the last one is eddy current, kind of type, you can, use this to to find out, problems with the weld. Basically, it uses to evaluate the subsurface discontinuities. And,
Here I have a reference.
that's a
weld
typical
sample
weld.
in which I have a base metal notch, cap notch, and as well as a notch in the heat affected zone. So now I will show you how we can detect these notches. First basic principle is I will keep my probe on the base metal and I will identify my 0 point is here. Then I will scan the base metal. You can see my indication, my crack indication is going towards upward. Now the question.
So these were some quick updates on weld testing. This kind of concludes the program. If you got some good pictures of the projects, we'd love to have some pictures. We're going to try to do a program evaluation here, see if it works. The question and action didn't work, so I don't know if the poll will work. Let's see. No, it doesn't work. So poll doesn't work either. If you need to reach me, my email is de@geotecheng.com, 713-699-4000. Send me your questions because the question here does not really work very well. This program is going to be on YouTube. We're going to have a bunch of webinars, so you're going to be on our database. Again, thanks ASCE for the opportunity to present here. Email me your questions. For some reason, the Q&A does not work on Zoom. So that concludes the presentation. I appreciate your all time, and I hope to see you guys soon. Thank you very much.